Welcome everyone, and yeah, thank you for taking the time to be here. We are excited, really excited. So it's been a long journey to get here, but yeah, I've been talking with you at some point in the last couple of years around this crazy idea of creating a camera trap for actually conservation. So I'm really excited for this day. So yeah, I'm going to start sharing my screen and we can take it from here. But main thing today is just a quick update of what we are trying to do, where we are at, and how we can all leverage the effort so that we can make the most out of it. So yeah, passing it on to Carolina to take it from here and yeah, to provide more information of what we're going to be doing and what we are going to be talking about. All yours.
Thank you, Victor. So, hi, everyone. My name is Carolina. I'm the product manager for Wildlife Watcher, and we are very excited to present our progress so far. But first, we'll start with just a quick introduction to how Wildlife Watcher came to be. So, yeah, that's the slide. So, we identified a few issues with the equipment currently available on the market. Firstly, the triggering mechanism was not reliable. Some animals were overlooked, missed, or not captured altogether, especially when it came to cold-blooded creatures. And most of the equipment was designed for larger and slower mammals. And also the time and effort required to process images often just caused delays and outdated information being used in decision making. And scientists had to sort through hundreds of images to identify and classify the footage. And a proposed solution is a camera that triggers when it detects movement of not only warm-blooded but also cold-blooded creatures of all sizes. And we also aim to provide an efficient framework for image processing and real-time notifications when certain species are identified by camera and its machine learning models. Next slide, please. So we divided the work into certain components, and today we'll talk in more detail about the motion sensor, our supported cameras, the flash, machine learning, the case, the power consumption, short and long-range communications, and image processing. So let's jump in, and I'll pass on to Victor to introduce each concept.
Awesome. Thank you. So yeah, as Carolina mentioned, the whole project came to be because of first-hand experience of getting frustrated with what is out there and trying to repurpose tool that is not designed for conservation. So we broke down these components and we're going to be going through them. What is the main objective of the Wildlife Watcher and where we got to and what are the potential next steps. So for the motion sensor, we wanted to have a camera that trigger when there is movement in front of the camera, so when it's within the field of view. It might seem oversimplistic, but we just wanted to keep it as simple as possible so that we have something out there and then we can start moving on to more complex features. What we have achieved so far is we have a system that it detects motion based on visual information. So it is not using the common passive infrared sensor that is found in most of the camera traps that we use, that biologists use. So it is looking for changes on pixels. So it is just a camera looking for changes on pixels. It does work in low light, So we have tested it, and on an open field with moonlight, it does work. It detects motion, and it consumes very low power. So similar to the passive infrared sensor, similar numbers. So at the moment, we are looking at 4 AA batteries, and the motion sensor, it can be active for months. So that's where we are at with the motion sensor. It does have low latency. So for fast moving animals, the time that takes from the sensor to recognize there is motion to actually taking a photo is crucial for recording those fast and speedy animals. So the advantages of using the camera to detect motion is that it can take the photos straight away. And then we have a system that it can work for fast or slow moving animals. So basically what the camera is doing is looking for changes of pixels between one image and the next one. So we can say, look for changes of pixels between images that are taken within half a second or less than half a second. But if it's a slow moving animal, we can say, okay, look for pictures, look for movement within pictures taken every 2 seconds or 5 seconds. Something here, for example, snails and another animal, a slow moving animal. So what is next? What are we thinking and what are we working on to refine the sensitivity levels so that we have 3 options for the users: low, medium, and high, and more information on what low, medium, and high means in terms of actual number of false positives that you have if the camera is facing down, or if the camera is facing other ways and there is always background moving, then you should have it on low, and what is the false triggers that you get. So some actual explanation of what this mean on the field. From experience, the current camera traps have these options, but you never know what it actually means until you get the SD card in a month's time, and then you're like, oh, I should have put it on too low because now I have a lot of images, or like, oh, I should have put it on too high because I don't have any images. And then looking at the illumination settings. So we need to keep on researching what the situation is for the motion sensor during the night. And we are looking at an option of having a small LED to flash every time that the image is taken. So it has enough light to detect the motion, but it doesn't have like a bright flash light. That's with the motion sensor. Going through the parts here of the camera traps, and then we're going to be able to provide a little bit more of what is next in general. We love everyone to be able to contribute and to share your thoughts. So the next category element of what makes a camera trap is the cameras and the quality of the pictures. So our objective here is to have the camera to take appropriate quality pictures that fit the use case. What we have achieved is the main camera that is looking for motion. It can take photos and it can be used for machine learning purposes. So more on that later, but the main camera not only looks for motion sensor, but it can take photos. And then we have a secondary camera that can take higher quality photos. So we can always swap the camera to have different features in terms of we have even more higher quality or with different capabilities, wider angle, or whatever we want to set it up. There will be costs with that. The more higher quality that you want, the more expensive the cameras and the lenses and so on. We also achieve the option to set up the camera onto a time lapse on a motion detection. So we can compare it with what previously has been done. You've been doing research with cameras and you use time lapses instead of motion detection. You can set that up and you can even set up both of them if you want to compare what you've been missing in a time lapse research. And all the photos are saved onto an SD card, which is more complex than what you expect. What is next? We need to research how to auto-adjust the exposure. We know from experience that overexposed and underexposed images are really hard to find out what's going on. So if we can find a system on the camera that is looking for options to adjust the exposure, that would be good. Research what higher quality image means. Is it something that it enables us to differentiate between two similar looking lizards, or is it going to be able to identify certain individuals from within the species? What is that like higher quality image meaning in terms of actual conservation work? And then we have we need to create the option to enable people to take videos or a sequence of images. At the moment, it's only taking sequence of images, 3 images, when motion is detected or when you set it up in a time lapse. Next, flash. We want the animal to be illuminated when a picture is taken at night. We have achieved LEDs that flash when a picture is taken, and we have been testing it with the camera facing down. What is next? We need to look at the option of providing white versus infrared flash, and we need to auto-adjust this flash brightness depending on the light conditions. I know that, yeah, flash is also a tricky one, and being able to see how the images are going to look with the flash, it can save you a couple of trips from going up or going down wherever you set up the cameras. On-device machine learning. This is an area where it excels our camera. So we have the capabilities to run machine learning on the device, and the objective with that is to identify specific species when they are in the field of view. So we have created a user-friendly pipeline to build these models. So using a no-code approach, people can upload onto a third party on Edge Impulse we are using the images to upload 100 images or 200 images, and then you can create just with a few clicks machine learning model. Depending on how accurate it is and so on, then you can do more iterations. But the pipeline is user-friendly. That's the main thing, that anyone theoretically following simple guidelines can generate their own models. We also have the approach to transfer those models that you create on the browser onto the actual camera. We are doing that actually manually. So we need to the next steps is to make it also user-friendly. And we have successfully trained a run detection model. And according to the stats, it is looking promising. We just need to also test it on control environments, the ground. As I mentioned, At the moment, the models that we create, we upload them manually onto the device. So we want to enable the users to transfer those models via mobile app, just to make it easier for everyone. Option to have a general animal model, and option to have multiple models loaded onto the camera. So those are the next potential steps that we might be looking at. In terms of the case, we need a case that is light, durable, and waterproof, and easy to handle setup. So we've been 3D printing the cases ourselves, and what you can see here on the right are a bunch of iterations of the device. So yeah, it's 3D printed. And the main thing is that you will be able to remove the batteries and the SD card. So those are kind of like requirements that we need to be able to deliver, and is relatively easy. So you don't need any special tool or anything like that to remove them. And those pictures that we see is from development purposes. So that's not the ultimate product case, and we are still testing. And it can be mounted onto different setups. So it can be a strap onto a tree, or it can be mounted onto a tripod, or different ways. So we just wanted the flexibility that current camera traps have, really. What is next? We need to refine the case and test for durability and watertightness. And also we are looking at the ability to enable users to plug other devices. So whether it's speakers or another camera or microphones or anything else, that will be more enabling people to set it up on whatever requirements they need. But we wanted to make sure that it is as lean as possible, so that we don't have redundant electronics and complexity. In terms of power, the objective is to have a camera that has enough power to last at least a month on the field, on average. So at the moment, we are looking at 4AA batteries. They are a universal way of powering electronics. So no fancy stuff here, nothing that you need to get from Waga.ai or complex stuff. 4AA batteries for the time being. And the whole design of the camera is built for maximizing the power consumption. So anything that we activate or use, we keep in mind what is the actual power consumption. So the motion sensor and the machine learning models that we run are very minimal in terms of power consumption, and it has some drawback for the machine learning model. For example, it's not going to be as accurate as if you run on a computer with GPUs, but it can do some of the work that we are interested on. Communications, also a little bit more on that later, but we use efficient communications systems so that we don't try to run out of batteries from weird communications. And what is next? We are looking at the potential also of adding other batteries or solar, to make sure that we have well documented processes of how much actually power consumption is taken every time that an image is taken, how long that a batteries can last in normal circumstances. In terms of communications with the device, we want the camera to communicate wirelessly with a mobile so that it's easy to deploy the camera on the field. So what we have achieved is that's connect via Bluetooth. We have a mobile app that starts and deploy and ends deployments. More on that later in terms of deployments, if people are not familiar with that term. It can add projects so that you can have multiple devices, and it has also the ability to tell you what is the battery level, the SD card space, whether you need a new firmware update, and so on. So the main thing from here is to try to remove LCD displays from the camera or extra buttons that we don't need. Everyone has a mobile phone with them, and we just wanted to use those capabilities in terms of GPS location and time and so on. You can just share those pieces of information from your mobile. You don't need to have more equipment on each device, on each camera. What is next? We wanted to add the option of drafting deployments and using the camera offline. And we want to enable this option to upload the machine learning models and receive notifications via the app. In terms of the long range communications, so short range is meter or two, long range is everything else. When you have the camera out in the wild and you just want to receive notifications or connect to it. The objective for that is to enable the camera to send real-time notifications. And the choice that we are doing at the moment with communications is using the LoRaWAN approach. So again, maximizing the power consumption and enabling to work in remote areas. We have achieved the camera to provide heartbeats in terms of, yes, the camera is still working. I'm having 50% of battery and I have taken 20 images. And also to detect the machine learning model that I have is running a rat detection model, and the model is saying that there has been taken an image of a rat. So sending these only text messages, and we have connected it to Trap and Set. When the device says there is a rat here, then automatically uploads to Trap and Set that there is a rat observation in that area. What is next? We need to customize the content of the message and how often do we want to send these heartbeats. Is it like once every 10 minutes or once a day, or what will be that? Depends on the user, but we need users, to tell us what you want. Integrate with the mobile app. So at the moment we have it connected to send the messages to Trap and Set, but we will need to connect it to send messages to the mobile app and any other platforms that people might want. We want to enable the option to communicate device to device until it's able to send a message via LoRaWAN, so the idea of mesh networking. And we want to explore also other communication methods. We know that people are not only relying on LoRaWAN, and if people have access to other communication methods, then we will be able to cater for that. Image processing. The main objective here is we wanted to design the camera so that it's easy to go through the photos, really. So a user-friendly framework to process and manage the footage. We have set up the camera so that we follow standard camera trap formats. So that way, when you have the SD card, you can see that the camera was active from when you started the deployment until when it finished. Every single image can be tracked to that deployment. So no more getting an SD card and trying to figure out the location of where the images come from and when it was actually set up. Yeah, you have an image that finished on the 20th of May, but was the camera still running for a couple more days and it didn't see anything? So all those kind of situations, we wanted to have the information available on the camera. And the ability to use any software that is available there in terms of camera traps software, Adax AI, Wildlife Insights, Trapper. There are tons of software out there to deal with camera traps, and most of the software is now moving to use this camera trap format. So the ability to drag and drop the content from the SD card onto your software, and the software recognized, yes, this camera was set up by Victor and it was set up on the 20th of May and it has all these images and this is the location and so on. So you don't need to actually tell the software where the camera was set up because you already did that on the field from your mobile app. So what is next? We want to test image processing with other tools. We know that there are other software out there, so we wanted to test and provide guidelines for people to use the camera with other software there, and to connect it to GBIF and integration with local context. So the fair and care principles, following the fair and care principles. That's a lot of parts of what makes a camera trap, and our philosophy, where we are at that moment, and what is next. So hopefully I didn't overwhelm all of you, and you might be able to have a look through the presentation later if there's anything unclear. But to find out more, I will pass it on to Carolina to let you know where you can find out more.
Thank you, Victor. Yeah, so if you're curious about the product planning, the development process, and how different components fit together, as well as how the camera works, we have a few resources that you can review. First is the Notion page that contains all the details about the project, the camera functionality, and the team. And the second is a user guide that explains step by step how to work the system. And that's from setting up the camera and starting deployment to ending deployment and image processing and everything in between, training models, etc. And I'll send out the links to these pages shortly after our meeting. And if we go to the next slide. So moving on to the feedback section of our meeting, we have sent out a short form asking you to rate some proposed high-level features in order of their importance. Thank you so much for the answers that we received. I know that it was pretty short notice, so don't worry if you haven't had a chance to cast a vote. We can have a little discussion in a second. But looking at the responses that we have received, interestingly, there were some features that everyone sort of agreed on and rated similarly, and some with large disparities. On average, the feature that seemed the most important was the long battery life or solar power options for long deployments, and that was followed by the accurate motion detection, both to reduce false positives and to capture fast animals, and then the ease of setup and use and weatherproof design, and then the price average somewhere in the middle, so aiming for that under $200 bracket. And finally, equal last but not to say unimportant, were the real-time recognition of the target species, so the machine learning models on camera and high quality picture day and night. But it's worth highlighting here as well that the real-time recognition of species and the price were the controversial ones, as they were both rated 1 by some, 6 by others, and some voted somewhere in the middle. And similarly with the motion detection and ease of setup and weather resistance, a few divided opinions here. Obviously that's depending on the requirements of your project. So now, after everything that Victor has presented and hearing about how the features were rated, I would like to open the floor to any questions about the product or the features existing or new features, and maybe open a discussion about what's coming up. So I know that some of you scored differently than the average rating, so we'd like to hear your views, maybe what was the most important feature to you and why, and are there any features that you feel strongly about? Maybe your opinion has changed as well after what you've heard today, or maybe you didn't have a chance to vote at all. And apart from that, so the most important feature to you and why, we would also like to hear about your current frustrations and maybe the biggest limitations of the existing wildlife cameras from your experience. Is there anyone that would like to share first or ask any questions?
Amazing progress. Looks awesome. Are we still looking at sub 200? What's your feeling around price at this time?
Long story short, depends. But yeah, I think that the idea is to try to have the simplest camera, 200 or less.
When can we start using? What's sort of the timeline from here?
Yep. So we have the electronics for development purposes, where we are still finalizing those areas within motion sensor and so on. But we are narrowing down what the basic camera look like and what components we need. So over the next couple of months, we are going to start producing those cameras that are going to be more user-friendly. At the moment, the cases that we have are very focused for development purposes. So yeah, over the next couple of months, the idea with this Kōrero is to touch base with all of you and start planning for giving you a camera or two, hopefully November, December, so that over the summer we can start the field sessions. That's the idea.
Awesome. Great. So have you done field trials with rat detection models, or is it more in the lab at the moment?
More on the lab at the moment.
So I guess, yes, we're trying to figure out the next steps from here and prioritize. So field testing with the rat would probably be somewhere highish on our agenda as well. But there are so many other features that we also want to introduce. So we would find it really helpful if we could get some of your views of what you think the most important one for you would be. Just because this is how we want to inform our development in the future as well. We want to have a feedback-driven design as well. So we want to really listen to users and implement the changes that the users drive, essentially. But we can move on to...
I was just going to say, super amazing work. Like, you guys have done a lot of work already. That's really awesome to see. Thanks for the update. I think the work to use a different detection mechanism away from PIR sensors is hugely valuable. It's like a real game changer, not just for cold things, but also just for fast things. Stoats, often you get a tail, so yeah, I really congratulate you guys on that. Thinking from a monitoring lizards and invertebrates kind of perspective of what I'd be really keen to grab some of these for, cost-wise, for me personally. Other people might have different views, but I reckon I would call $400 or less, probably I'd still call that like low cost, that you can pick up a bunch of them and deploy them for still a reasonable cost, in that same range as other kits going for. But yeah, being able to bring online some of the sort of end-to-end type processes that you're talking about as well are really valuable if you can streamline the journey from put a camera out to have a Y-axis sonograph or the answer that you're wanting. That's primo, so awesome stuff.
Perfect, thank you, Jamie. Does everyone agree? Are there any differing opinions?
Sub 200 be good.
Okay.
No, we're a conservation organisation, so limited funds.
Yeah, and would you be looking at sort of higher quantity as well, or is it also, for?
Yeah. The goal is out here. So we're working on a project to reintroduce kiwi out into the Muriwai area, and the area that we're looking at, we're really looking at a virtual fence. It's about a 12K perimeter. You'd want a camera every 100 meters minimum, and then quite a few on the interior as well. That's kind of what we're thinking. Funding pending.
Yes, it's good to hear. Thank you.
Yeah, I mean, ideally, we would love to be in a position where for conservation projects, we will be able to do a reduced price in sponsorship with somebody, or at the end of the day, we need to pay for the electronics, and we need to pay for the maintenance and the development side of things. But again, it's we are a charity, so no kind of hidden costs behind that. But yeah.
Cool.
Great. Before we move on, are there any final comments or questions?
How much have you done a bit of testing with the LoRa communications? We've been running a LoRa network out here for a while, just with sensors on live capture traps, and it works pretty well. But man, it was quite challenging just getting it into the deeper valleys and kind of dense bush areas. It took a lot of effort to get the receivers in the right place, and I think probably the mesh approach is ultimately going to be better in kind of more rugged territory. Have you done a lot of testing? I guess with Taranaki Moanga, you probably have a similar sort of challenges, I'd imagine.
Yeah, definitely. In Taranaki is relatively good LoRaWAN connectivity, but as you mentioned, valleys and
Tobin, did you want to jump in with that?
Yeah, I was going to say I can jump in a little bit with the LoRaWAN side. So that's definitely something we've acknowledged and something we're trying to tackle in terms of like those deep gullies and the true remote locations. At the moment, we will be tapping into the LoRa infrastructure through the gateway network. So it'll be a node connects to a gateway, and as long as it's in reception there. However, we are brainstorming ideas of like mesh networking, so to have better infrastructure, so the nodes pass the messages between each other to get to a high point to pass, to be able to tap into those deep gullies and everything. So there's ideas to extend features down the track like that mesh networking, which will hopefully solve some of those challenges.
Yeah, cool.
Thanks, Tobin. Okay, we can probably move on if there are no more questions. Victor, if you could go to I think it's the last slide. Yeah, there you go. Thank you. So thank you for the questions. Again, we really value your feedback. It's really useful to understand because that will help us shape our product. And then finally, to touch on the next steps, after this meeting, we will send you a more detailed list of features. And again, we would like to ask you to order them from most to least important in your opinion. This list will be a little bit more extensive. It will be everything that Victor talked about today. You don't have to rate them all. If you think that some are not important to you at all, then just don't rate them and just order the ones that you think are important to you. And then we'll collate this feedback and from there we'll just refine the beta version and what it will look like, and we'll also reach out to you separately to discuss your projects in more detail to make sure that the Wildlife Watcher caters for your requirements and just to make sure that we can offer you all the support that you need. Mostly will be a chat about your goals, the species that you're trying to detect, the number of cameras that you might need, and your timeframes as well. So that's the plan part. And we'll also continue with the product development and testing and basing our steps on our next steps on your feedback. And finally, when the beta version of the product is ready for field deployments, we'll start prepping the cameras for shipment, making sure that you're supported from start to end with preparations, with the setup of the cameras and the deployment. And throughout this process, we'll also ask you to communicate with us regarding the ease of use, any issues that you've experienced with the cameras, and any improvements that we could implement so we can ensure that, again, we have that feedback-driven development. Are there any questions about the next steps or anything to add from you, Victor? As Victor said, the timeframes are sort of the next few months, potentially October, when the cameras might be available.
Just highlighting that we are doing this for you guys. So just to make, life easier in terms of whatever conservation mahi you are doing. So yeah, please, if you can help us finding out what are those priorities for you, it will be awesome. And looking forward a lot to being able to discuss how many cameras we can give you, more about your project, and actually seeing the cameras having an impact on the ground. So yeah, excited to be here.
Yes.
Awesome.
Thanks. And again, that's it from us. Thank you so much for being here. Thank you so much for your involvement, for your continuous support for the Wildlife Watcher and Wildlife AI in general, and your interest in our technology. If there are any final questions, please ask. Otherwise, please expect a follow-up email from us with a summary of this discussion and more regarding the next steps and the forms and booking those individual calls as well. Thank you so much.
Awesome. Thank you. Great work, guys.
Thanks so much for your time and energy, team.
Thanks a lot.
Thank you, Dale.
Thank you. Cheers, guys.
Cheers. That's awesome stuff. Thanks.